Hi everybody, here's Mrs. John back again with you, and this time it's to answer one of the questions on the query sheet, and it is the question based on resultant force, and it's the question on this side of the page. There's actually 8 questions, so this is question number 8, and it has to do with a girl on a lift. So let me just read through the question and I'll talk you through it. So a girl stands in a lift at rest. So that's your lift at rest. There's a girl standing on the lift. What is the nature of the force that balances her weight force? So because she's standing on the floor, her weight force acts downwards and the reaction force from the floor of the lift acts upwards. So let me just draw those two. So weight force. Now this is something that doesn't change. Weight force, gravity force, and then you also have an equal and opposite reaction force. Because it's stationary, your weight force is equal to reaction force. Because there's no acceleration, it's 0. So I've just put that over there on the side. Okay, so she knows that gravity is acting on her because she can feel the floor of a lift supporting her. Then what happens? So this is instance 1. The lift now starts to go down, and so for a moment the lift accelerates downwards. So this is a lift and it's accelerating downward. Now the moment it's accelerating downward, the word acceleration brings to us the term unbalanced force, and the unbalanced force and the direction of acceleration are the same. So this is what we need to keep in mind. Now the two forces that are acting on her are no longer balanced. Which one has changed, and is this, whatever has changed, is it now smaller or larger? Now the thing is, we always need to remember that the weight force, no matter what's happening to her, whether she's standing or whether she's going up or down, accelerating on the lift, it doesn't matter. It's always the same size. So this doesn't change. So that means the downward force has to be bigger. So the only thing that's actually going to change is the reaction force. And the reaction force is going to be smaller. So reaction force is smaller than weight force. Just going a step further, your feeling of weight depends on the reaction force. So if your reaction force is smaller, you're going to feel lighter. Okay? Right. Then, explain why she feels lighter. She feels lighter because the feeling of weight is based on the size of the reaction force, and because the reaction force has become smaller, she is going to feel lighter. Okay, so that's part C. Now she's going down at a steady speed. Now if she goes down at a steady speed, that means there's no acceleration, so it's going to look like the first diagram. The two forces are balanced. The size of the reaction force becomes equal to the size of the weight force. Okay, then the last scenario is, lifts go up and down because of a cable that's connecting it. Now the cable which holds the lift breaks. So that's my cable breaking. And the lift falls freely with an acceleration of 10 meters per second squared. How large is the reaction force now? Now what actually happens, I try to draw, it's actually the floor of the lift is falling at the same rate as she is falling. So she's actually probably not even in contact with the floor. So there's nothing to support her. So the reaction force is 0. The gravity force is still there, but there's nothing to hold her up because she's falling down. And so what happens is she is going to feel weightless. So the answer to the last part, F, is that she'll feel weightless. So I hope you understood this, and I'll also write this out for you. The answer is on the Google slides that I've made. So bye for now, and have a nice evening.